So next up is Swisscom, and we're going to learn a little bit more about what they are doing, and working on with their automation efforts together with Cisco. So Eugen, welcome up on stage.
Thank you. Hello, everybody. My name is Eugen Serban. I'm a net DevOps engineer at Swisscom since 2022. I started as a QA engineer at Ixia. Some of you know it. They make testing devices. Then I moved to network engineering, network architect. Then I came back to testing network devices, and now I'm wrapping everything up in a DevOps engineer. So about us at Swisscom, we are the oldest and the largest telecommunications provider in Switzerland, and we do everything telecommunications related and IT. And we have a lot of services like mobile, internet, broadband, B2B, enterprise solution, TV, everything. And because we are old, we have a lot of legacy network. So this is the state of the network that was present when I joined in 2022. And here is where we want to be. This is actually the network is built. Not all the services that you see on the right-hand side are migrated, but the network is there. So the way we build the network, we partnered with Cisco and use SRv6, of course, since it's the newest kid on the block. All the network should be automated. There are no manual changes in the network. Everything goes through NSO. And the network you can interact with it only via ODMs. So if you know TM Forum, you know what an ODM is. We have an API gateway, and the calls go there, and then they are spread down southbound. You can see more information regarding this if you want on YouTube, where my colleague Martin Gysi had a presentation. But what I want to focus is how do we work on automation? How do we create this automation? So we have, of course, the pipelines, and everything starts in the development stage. And in the development stage, we create by hand, we create the service on the network device, we test it, then we create the template for NSO, then we create the code for NSO, and once we commit, we push, git commit, git push, the automated process takes over, and Jenkins moves it to the development, to the dev test pipeline, where it's built. The unit tests are run, and the uploads and results are uploaded in Artifactory, where everything can be used. In this stage, we have NetSIM devices. Of course, we cannot have a real network for all the commits that we do. And then, automatically, if all the tests passed, the code is pushed into integration. The difference between the previous stage and this stage is basically the way the network is built. For the first time, we have physical devices. It's iOS XR devices, the same devices that we have in production. Everything is the same. Of course, less, because we cannot have thousands of devices only in the lab, but the rest is the same. Here, the acceptance tests are run, or should be run. Sometimes are run, sometimes they are not. Most of the time they are. We have, of course, traffic generators. In this case, Swisscom decided to use my legacy competitor Spirent and not Ixia. For fiber cutting, we have Ecola, so we don't have to go there and cut fibers every time. We have an automated process. And then, when the process stops here, when we create a release, so we have all the features, we put them together, we create a release. This release goes to the end-to-end stage, where we have a different battery of tests. We have the sanity tests, which are less than integration, but they are different kind of tests. They are focused more on end-to-end integration. And here we have different IT systems. So as an example, we have oscilloquartz, which tests the PTP, which is useful in case you want to bill your customers at the second and not at the minute. We have a Netcracker NDO for inventory. We have Tor, which is an internal built IT tool, and basically it's the orchestrator. It orchestrates the transport network. And then the final two stages are the pre-production and the production. The differences between the two stages are that, of course, the pre-production doesn't have any client traffic. And here we test in case of hotfixes. If we have something that cannot go through this whole process, which basically for us now takes 1 week, since we create a release, all the testing processes, we take time to test the release. If we have a hotfix, we can speed that up ready to production, and we test it in pre-production. And of course, in production, we don't have any fiber cuts. We have normal construction workers that cut cables, and traffic generator, it's our customers that pay the bills. Okay, so if we focus only on the development, because this is why we are here, NSO-ARC comes into the development stage. So let's focus more on why we use NSO-ARC. We use it because we want to implement something that in Agile is called test-driven development. Test-driven development basically is you first create your tests, then you create code that makes the test pass, you run the test until they pass, of course, so you iterate on your code. When the tests are passed, you add new tests until you reach perfections. So, what is a net DevOps engineer? A net DevOps engineer has 3 roles. The first role is a network architect. So the network architect is I call it the legacy network engineer. He goes on the device and he tests by hand the new service. He creates the configuration, and then he provides the netconf output, because we only use netconf in our network. He provides the netconf output to the next role, which is the network developer. So the network developer, what he does, he basically creates the NSO code. He takes the template, he creates the Python code and everything that is related to NSO, and he creates the unit tests that are run in the dev test stage. And the final role is the tester. What this role does, he takes the final NSO code, use it into our integration lab or in his own development machine, and basically creates the next battery of tests, which are used in the later stages, or test the code by hand. Now, the tools that these roles have, I call them role and not persons because I do all these 3. Not for every project. We try to switch and have a role as a network architect for some feature, and developer for other feature, and tester for other features, so we can switch between us. But it's basically the same person that has these tools. So the first tool that we have is a copy of our production network. And this copy is created using Container Lab and XRD. The second tool is a Docker container that runs NSO, the same version that we have in production. And the third tool is CXTA. Does anyone use CXTA? Except Swisscom? No? You should check it out. It's really cool. It has a lot of features, and if you integrate it with CXTM, it brings you a lot of value. Now, let's focus more on the development role. What does a developer do? So a developer gets his feature or bug fix request in Jira, and he clicks a button, and then a branch is created in Git. Then he starts to create the code, Python, XPath, whatever. And the final thing is makes sure that nothing was broken that was working before. And here is where CXTA comes into play. You can see here an output of a test that I had run, and it's failing. Is this an expected failure? Is it failing only where the new code is, or it's failing in other places that are unexpected? So you can see this in the report. And in my case, because I control this, yes, I just removed IPv4 from the VRF, and this is expected. Now, how do we use to create this kind of test? I think in 2022, so that was before I joined, there were 2 developers that spent 2 months creating this kind of test for one package. It took them 2 months. This was very error prone because you have to type stuff, and it was hard to maintain. Imagine when you change your service, you have to go through all the tests and modify everything where stuff has changed. And then ARC came to the rescue. And you can see here the new triumvirate. What is ARC? ARC is magic. And this is what it should be. And Michael is here, and he can explain the magic. But basically what it does, it creates the test for us. Of course, you have to give it parameters, but the tests are created, and you can finally reach the same picture that I showed you before, and we can do the TDD, the continuous testing and developing. The next thing that we did was to try to automate this test case creation. So we had bash scripts for every package that we have that automatically called the NSO and created the test cases for us. The problem with this approach was that bash scripts are not dynamic, of course. So every time we had to add a test, we had to go back to the bash script, add a new test, add a new service C2 for the new service that we wanted to test. Other issues that we had were that for services that have encrypted passwords, when you create your test on one NSO, which is in development, the password is encrypted. So when you run the test on a different NSO in Jenkins, the password don't match, so the tests were always failing. So the bash script took care of this. It basically changed the password from encrypted, and we put password 1 through 3 as everyone who's security conscious would. And of course, the bash script cleans files that we don't need that are generated by ARC. It changes the name files to match whatever we need in Jira, and it puts them in the places that we want. So everything was tied with the make file, so you can just do make clean to remove all the previous tests, and make create, and it recreates all the tests. And you notice it recreates all the tests. So it means that for packages that we have packages that have 50 tests. It took sometimes 1 hour to recreate all this. So you do your make create, and then you go, you take a coffee, you come back, you take another coffee, you start to shake because it's too much coffee. And then at the end you come, and then you do your git push, and finally Jenkins is happy and moves forward. And because my background in testing, all my colleagues were coming to me to try to fix the issues that they had. So what I did, I created a package that does what the bash scripts do, and it does also what the pipeline does. So it's a wrapper on top of NSO, written in Python, of course. It's a package and I called it ARBALETE, which stands for ARC Remediated Boosted Automated Privileged and Enhanced Testing Environment, which is a mouthful. But I chose it because ARC in French means bow, and ARBALETE means crossbow. So basically, my idea was that it's an easier to use bow. So the beauty of having this as a NSO package is that we could store the information about the test in NSO. You just load your test in NSO, and you can target a test. You want to recreate only one test? Fine, just recreate that one test. You don't have to wait 1 hour if you only need to recreate one test, which happened often because our tests, they cover different situations. It is portable, so as long as you have NSO installed and the packages are there, you can just run this and it works fine. And it's scalable, you don't have to run everything. Now, how does it work? I wanted in the beginning to do a live demo, but I didn't trust my VPN, so I will show you a video instead. If I have video. Yes. So in this case is the test creation. As you can see, the test folder, the one that is provided automatically by NSO when you create a new package, is empty, and we use that one. You go to the service seed folder, which you have to create, and then create a new file, and you paste it here. So basically, this is the test. In the beginning, it has some information for Arbalet that it needs, the test case description, the author, the review date, because we don't want tests that are too old, so we review them often, every year, but it's often. Still better than nothing. You can provide other information about the test, so you can say what you want in the test if it's not self-describing, and then you just put the parameters for the test. So in this case, I create a VRF without IPv4. And that's it. This is how you create a test. And then call the makefile, which calls NSO via REST. So it's a curl call. It prepares Arbalet, so all of this is in NSO, and then it creates the test case. It takes a bit because we need to make sure that NSO is clean. So what I do, I take a commit. So I take the commit in NSO, I create my service, run a robot, which takes some time, and then revert the configuration on NSO to make sure that the NSO is in the previous stage. And that's it. And here you can see the created robot test case. You don't even need to know robot, because all this is the magic that ARC handles. Now, the next demo is what happens when you want to regenerate the test case. So still in VRF, because it's, I chose this one because I created this package and it's a simple one. The first thing that we do when we start developing, we run the test. I run this test just to show you how we run the test, but of course we know that they pass because the code is the one from the clean branch. So if it passes in Jenkins, it should pass in our case. So everything is green, which is awesome. We can start developing. So, yep, everything is green. Now we can start developing. I just changed my template here, and what I want to do, I want to disable IPv4 for everybody, because anyway, IPv4 is legacy, so nobody's using it. Thanks for the encouragement. Redeploy the package to take the new configuration. And then let's try the test again. What do you expect here? I expect it to fail because the service is not the same. So it's running the 3 test cases again. OK. And now the question is, did it fail how I expected it to fail? Let's check. OK. So the only difference is IPv4 is not there anymore. Cool. Now we know that the modification that I did is what I wanted. So the next step is to recreate the tests. And the recreation of the test is the same, make create tests. And it works the same. I will skip because it's 1 minute, and it gives you an output of each test that it recreates. OK, the 3 test cases that I had are recreated. Now I run the tests again, just to make sure that nothing else is broken. Everything is green. Cool. So the next step is to go on vacation, of course. But before that, git commit, git push. OK. So if we go back to this previous slide that I had here, you can see that the development now has the test-driven development arrows, which is the new addition that ties everything together into our test-driven approach. And of course, the test-driven approach is not ending in development. We use the same approach for creating the tests in integration and the later stages, but maybe that's for a different session. And that's it. This is what I had to show. And I invite Michael to talk us about why you created ARC. I'm sure that it was designed for us.
Yeah, so ARC stands for Automatic Robot File Creation. It was a project which is now 4 years old. I started in a hackathon thinking that we don't want to create robot for every test case manually anymore because it's too much work. So yeah, that's when it started. And seeing this amazing demo here, seeing my work on display is incredible. And thank you very much. It's a big honor to have this.
No, it really saved our skins plenty of times. I'm not an ISP. Well, now I'm an ISP guy. I wasn't before, so I really relied on this to make sure that the changes that I did in the network are not messing up the production.
Very cool.
We do have some questions, and I have a question. So if anybody else is interested in ARC, where should they go?
Well, ask CX, right?
CX. So it's a CX tool that you can get from CX if you have...
Absolutely. So it's tied to the CXTA and CXTM. So I've demoed 3 times, I think. Once with Martin Gysi in New York, and a few times on the Dev Days. So those are all on YouTube. So if you want more information on how ARC works, it's all available on YouTube. And yeah, and
OK, very good. Thank you, Mikael. Some questions here. Is it unit testing or regression testing we're talking about here?
Yes, semantics. Well, you can call it regression testing, but if you look in our chart of the pipelines, the regression testing goes into the integration stage. So that's why we gave it the denomination unit testing.
Okay. Very good. Are NetSim devices sufficient for covering all test scenarios on your network? Because there are differences and some features can't be simulated by NetSim.
Yes, the answer is no. That's why we have the next stages where we test on real devices with real use cases.
So let's move on. What do we have? Do you do any code level testing by mocking NCS module? Do you see any value in it as compared to just comparing the configuration output to decide one? Next question, or?
It's an interesting question. Well, the answer is, of course, no, because otherwise I would have answered it.
Yeah. Okay, let's move on. Maybe this one. Something we can take a look at. Oh, that was from the previous session, so let's move that away. Here's one around XRD. How do you handle XML templates when they contain config not supported by Container Lab XRD?
Yes, the way we created our code, even the production code, we have several ifs. If feature not supported by XRD or XRV, just don't apply it. So initially, we run the code, we see that it breaks on XRD, and then we handle this in our NSO code.
Here's a question about test-driven development, I guess. And I think it's going to be the last question. We actually have more, but...
yes, TDD is normally vice versa. But if you want to do it the proper way, that would mean that you have to imagine the output by yourself. And I didn't show you how the device diff looks, but it's huge, especially in XML, and it's hard to create it by hand. And that's why we do it like this. We could, of course, do that, and maybe we will do it, but not right now.
All right. Eugen, thank you very much. Mikael, thank you so much for the session.